Welcome back, everybody. This is our first class in JEE Mains previous year question for chapter Electromagnetic Waves from class 12th. Before this video, we have made several videos in this series, and all of those videos are available on our channels, YouTube channels playlist section. And we have also started a similar series for NEET previous years. So if some of your friends are preparing for those, then you can also guide them through those videos. If you like our content, then do press the like button on the video and do subscribe to our channel. It helps a lot. And also, if you like to support us financially, you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. So it will be a great help with whatever amount of donation with you can do. Now with this, let's start today's video. Now starting with the first question here. Uh, for a plain electromagnetic wave, magnetic field at point x and time. So we have been given a relation for the magnetic field, and we have to find out the corresponding electric field. So as mentioned that we have a generic equation for magnetic field, that B will be equal to B node times, here we have sine curve, so let's say sine of kx plus omega t. So comparing, we will get B node is equal to 1.2 into 10 raised to power minus 7, and K is equal to 0.5 into 10 raised to power 3, and omega is equal to 1.5 into 10 raised to power 11. So this inside expression should be same for electric field also. And if we see here that in all of these, the inside expression is same. Now for magnetic field, electric field, the magnitude will be related like this, that velocity of wave is equal to ratio of electric field to the magnetic field, and that velocity of wave is equal to minus omega by k. We cannot take it directly equal to 3 into 10 raised to power 8, because that wave can be in some medium. So we have to go with proper equation, that it will be minus omega by k, and here omega is 1.5 into 10 raised to power 11 with negative sign from the formula itself, and divided by k, that is zero point 0.5 into 10 raised to power 3. So this is basically minus 3 into 10 raised to power 8 meter per second. So what does it mean? That wave is traveling in the negative x direction. So if wave is traveling in the negative x direction, and we know that velocity in vector is equal to E cross P. So here wave is in negative x direction, so we can say direction of velocity is minus I. Now direction of field is here k, so magnetic field is in k direction or z direction. So what we can substitute here for the electric field, if we put here minus of j, then j cross k is I, so electric field must be in the negative j direction. So here this is j, this is j, this is k, and this is I. So both options C and D get cancelled, and it must have a negative sign here. So this is the negative sign. So option A will be the right answer for this question. Hopefully you understood it well, and best of luck. Now let us move to the next one, and let me slide it down first. So starting with here. For a plain electromagnetic wave, magnetic field equation is given. Instantaneous electric field we have to find out. So again, this is the same expression as the previous one. Okay, I think this question is double. So yes, this question is double. So we already solved it. This is in the first one. Now let's move to the second one. An electron is constrained to move along y-axis with the speed of 0.1 c, where c is the speed of light, in the presence of electromagnetic wave whose electric field is given. The maximum magnetic force experienced by the electron will be. So to find the magnetic force, we know that magnetic force is equal to Q into V cross P, and maximum value of this magnetic force will be equal to QVP. So here we have the, we can say, speed, and we have the charge. So we have to find out magnetic value of magnetic field, and that is related to speed like this, that velocity is equal to E by P. Now velocity will be, we can find out from this relation that velocity will be equal to minus omega by k, and this should be equal to E by P. Now omega is here 1.5 into 10 raised to power 7 with negative sign here, and k is already negative, so it's minus 5 into 10 raised to power minus 2 is equal to E. Magnitude of E is 30 divided by P. So this negative sign gets cancelled, this will go on zero point 0.3. So basically it is 3 into 10 raised to power 8 is equal to 30 into P. So this will go on 10, and we will get magnetic field is equal to 10 raised to power minus 7. Now we can find out the maximum force, so it will be equal to Q, that is 1.6 into 10 raised to power minus 19 into velocity, that is 0.1 c, so 0.1 into 3 into 10 raised to power 8 into B, that is 10 raised to power minus 7. Solving, we will get 4.8 into 10 raised to power minus 19 Newton, and that is option C here. Let's move ahead. The electric field in a plane electromagnetic wave is given by this relation. Magnetic field will be. So here, this is the direction of electric field. We know that electric field is perpendicular to magnetic field. So, or in short, their dot product, we can say E dot B should be 0. So let us see the options here. Here, this is the direction of electric field, and if we see option B, in option B, direction of magnetic field, assuming this is the expression for magnetic field, direction of magnetic field is same as for the electric field. So these options get cancelled out, because if we have same, if we take I dot I, we will get 1, not 0. Here we have two options with same direction, same magnitude, but with the cosine curve. Now we know that E and B are always in phase in case of EM waves. So if they are in phase and we have been given electric field as a sine curve, so electric field cannot be a cosine curve. So we have only two possible options left, A and C, and let us take dot product one by one. So for minus x dot x plus y dot direction of electric field, that is x plus y. Now we can assume that as x as I and y as j, so minus I plus j, and here I plus j. If we take their dot product, so it will be minus I square, that will be 1, plus I dot j, that will be 0, plus j dot minus I, that will be 0, and plus j dot j, that will be 1. So this will give us 0. So this option satisfies. Let us see the second one, that x minus y dot x plus y, and for that we will get I minus j dot I plus j, and this will be I square, that will be 1, minus j dot I 0, plus I dot j 0, and minus j square, that will be minus 1. So both of these options are satisfying the equation. So from this, both can be the answer. Let us apply another concept, as we have z component here inside the sign, means wave is going towards z direction. The velocity of wave is in the z direction, because if we find out the we know that velocity is minus omega by k. So here omega is already negative, so omega by k it will be positive, and that is given in the z form. So wave is going in the z direction, and we know that velocity component is equal to E cross B for a wave. So let us find out. Let's first solve for the C option, that if we take E cross B, now E is I plus J, so I plus J, and if we take cross product with option C, that is I minus J, and it will be I cross I, that will be 0, plus J cross I, that will give us minus of K. Now with negative sign, minus J cross I, or we can say basically J cross I. Oh, sorry, that will be uh, let me start it again. I cross I is 0, then we took J cross I, means we are taking it first, so J cross I was minus K. Now we are taking I cross minus J, so that negative sign here, so it will be I cross J, so that will give us K, and from that further we will get minus J cross J, that will be 0, so it will be basically minus of 2k, so it is in the negative direction of k. And if we take with this one, so what we will get, we will get I plus J cross minus I plus J. So again I cross I will be 0, and taking J minus sign as it is, J cross I, this will give us minus of k, and then going with the here I cross I, that we solved J cross I. Okay, I cross J, now we take, now I cross J will be K, and J cross K, J cross J will be 0, so this will give us 2k, or we can say in the positive k direction, and that is the required direction for the velocity. So the option with minus I plus J, or we can say minus x plus y, satisfy the second relation here. So option A is the right one, and option C is the wrong one here. Let us move to the next one. The magnetic field of a plane electromagnetic wave is, we have magnetic field relation, speed of light, the corresponding electric field we have to find out. So first of all, here electric field is in, we can say, is along x, E is along x, and direction of magnetic or direction of the wave, or we can say velocity, is along minus y direction or minus of j. So magnetic field has to be follow this rule, that V is equal to E cross B, and for that we know that velocity is in minus j, E is in I, so magnetic field has to be in the, we can say, oh sorry, correction here, we have been given magnetic field, magnetic field we have been given, not electric field, so this has to be corrected. We have been given magnetic field, that is in I, so here magnetic field is in I. Now we know that k cross I will be j, so electric field has to be in the negative k direction. So direction of electric field should be in negative k. So option, we can say this option will not satisfy, and option C also will not satisfy, as they both have direction in the positive k for the electric field. Now let us find the magnitude. Now magnitude of electric field will be given by this relation, that V is equal to E by B. So E will be V into B. So V is equal to C here. So 3 into 10 raised to power 8. And magnitude of magnetic field is also 3 into 10 raised to power minus 8. So this will give us magnitude of electric field as 9. So option B gets cancelled. So we have option D as a possible answer. So option D is the right one here. Let's move ahead. The electric field of a plane electromagnetic wave propagating along the x direction in vacuum is given by this relation: magnetic field at the moment t is equal to 0. So first of all, we have to find the generic equation for electric field, and then we can find its value at t is equal to 0. So again, let's see the direction. So here electric field is along, you can say it's along j direction, and velocity of the wave from the inside of cosine curve, it will be along positive x direction. So we know that v is equal to e cross b. So if we put substitute k here, so j cross k will be I, so we can say magnetic field will be along positive z direction. So option B is cancelled and option D is cancelled. Now going to the magnitude, we know that V is equal to E by P, and also V is equal to under root mu naught by epsilon naught. So it is E by B. Now value of E is E naught. So value of B is E naught times mu naught epsilon naught whole under root. That matches with option C. So option C will be the right answer for this question. Oh, sorry. Let us first of let us write the full equation. So magnetic field will become that B of t will be equal to E node under root mu node epsilon node and cos of omega t minus k of x. Now we have to find that t is equal to 0. So if we substitute t is equal to 0, then this will become E node mu node epsilon node cos of minus kx, and cos of negative theta is also cos theta, so it will be E node mu node epsilon node cos of kx, and that is option C here. So let's move ahead. A plane electromagnetic wave has frequency given, energy density is given in vacuum, the amplitude of magnetic field of the wave close to. So we have to find out amplitude of the magnetic wave. Now energy density in terms of, we can say energy density is energy by volume. It is equal to half epsilon naught into E square, and that is also equal to half B square by mu naught. So from this we can find out the value of B. So using these two, the energy density is given to us. So we have energy density as 1.02 into 10 raised to power minus 8. So from this expression we can write that B is equal to twice of mu naught. Mu naught is 4 pi into 10 raised to power minus 7 into 1.2 into 10 raised to power minus 8 whole under root, and this will give us, on solving, 16 into 10 raised to power minus 8 or 160 nano Tesla. That is option B here. Let us move ahead. In a plane electromagnetic wave, direction of electric and magnetic field are represented by these two. What is the unit vector along direction of propagation of wave? So we know that velocity or direction of propagation is given by E cross P, and we have to find unit vector. So let us find out their cross product. So it will be I, J, K, and for electric field we have K component only, so it will be 1 and all rest 0. And for magnetic field we have 2I and minus 2J, so 2 minus 2 and 0 there. So for I, if we solve for I, we will get 0 minus minus 2, so basically 2 minus of J, and for J we will get 0 minus 2, and for K we will get 0, so it will be 2I plus 2J, and if we take unit vector along this, so it will be 2i plus 2j divided by the magnitude. Magnitude will be 2 square 4 plus 4, that will be 8 under root, and under root 8 will be 2 root 2. So it will be basically I plus j divided by root 2, and that is option A for us. Let us move ahead. The electric field of two plane electromagnetic planes waves in vacuum is given by, we have two electric field at t is equal to 0, particle of charge q is at origin with velocity 0.8 cj along the y direction. The instantaneous force experienced by the particle is. So, as here we have two fields associated with here, two electric fields, so correspondingly we will have two magnetic fields, and we have to find the total force at time here at t is equal to 0, I think. Yes, at t is equal to 0 we have to find out the total force. So what we will do here, we will solve for each field separately and find force due to each of the fields, and then we will sum those up. So starting with the field first. So we have been given that E1 is equal to E node J cos of omega t minus kx. So here wave is along, we can say velocity or V1 is along positive x direction or positive I, and electric field is along J. We know that V1 will be equal to E1 cross B1. So let me adjust slightly thickness so that I can be better, write better. So here V1 is along I, E1 is along J. So B1 has to be along K because J cross K is I. So magnetic field is along B1 is along K. Now magnitude of magnetic field will be equal to B1 will be equal to C. We have relation that V is equal to E by B. This is the relation we are going to use here. So from this B1 will be equal to E no magnitude of electric field, that is here E no, divided by C, that is the speed of the light in vacuum, assuming both of the fields are in vacuum as already mentioned here. And the remaining part will stay the same with direction will be along K cos of omega t minus of kx. So this is for the first field. Now let us find out values at t is equal to 0. So at t is equal to 0, we have electric field equal to E node J cos of kx, and assuming that particle is at origin, yes it is at origin, so x will also be 0. So this cos term will reduce to 1 because cos 0 is 1. So this will be, so x is 0 and y will be 0. So we can say at t is equal to 0, x is equal to 0, y is equal to 0, and if there is some z, then z also will be at 0. So we have E1 equal to 0, oh sorry, E1 equal to E node J, and B1 will be equal to E node by C of K, and velocity will be along, the value of velocity is 0.8 Cj. So let me write velocity here. So velocity is 0.8 c times J. Now let us find the total force due to these fields. So that will be F will be Q into E plus V cross P. So Q as it is, E will be here E node J plus V will be 0.8 C of J, and cross B will be E node by C of K. Now in cross product C will get cancelled, J cross K will give us I, and this expression will result in E node J plus 0.8 times E node I, or what we can do, we can take E node common, so it will be J plus 0.8 times of I. So this is the total force due to the first field or first first electromagnetic wave, J plus 0.8 times I. Now let us start for the second one. For the second one we have that E2 is equal to E node K cos of omega t minus ky. So here again that velocity of wave v1 is along mine of positive j direction, and keep in mind here that while calculating the force we are taking velocity of this is the velocity of the particle or charge particle, and initially this was the velocity of wave, so both of velocities are different. Okay, so coming back, so velocity of the wave is along j, and electric field here will be along positive k. So from that we can find out that we suppose this is this is v2, so this is e2, so v2 will be in vector form cross product of e2 and b2. Now v2 is along j, e2 is along k, so b2 has to be along, if we take k cross I we will get j, so means b2 has to be along I direction, and similarly again magnitude of b2 will be equal to E node by C again. So expression for b2 will be that b2 is equal to E node by C, and its direction is I cos of omega t minus ky. Now at given condition that t is equal to 0, we have x equal to y equal to z equal to 0. So what we will get? We will get E2 equal to E node of k, and we will get B2 equal to E node of E node by C of I. Now the particle is same, and it is same in moving in the, we can say, y direction with the velocity 0.8 c. So force will be here, that force will be equal to q times E2, that is E node k, plus v, that is 0.8 c j cross b, that is E node by C of I. So j cross I here will be along minus k. Let us take E node common, so we will get q E node common, and this will be k, and this will give us negative 0.8. C get cancelled, negative 0.8 k as common, and this will give us q E node with 0.2 k. So this was the force due to first field, suppose that is F1. This is suppose F2 force due to the second field. Let us add both of the forces. So what we will get? We will get F1 plus F2 will be equal to F net, and that will be Q E node. We have I component, that is 0.8 of I. We have J component, that is J, and we have K component, that is 0.2 times K. And if we match it with the given answer 0.8 ij plus 0.2 k, that is our option D. So option D is the right answer for this one. So with this, we end this video here. Hopefully whatever we have covered is helpful to you. Again, if you have any doubts or suggestion, you can put them in comment section. I will try to resolve them. And if you find this video is useful and you like to donate, then you can scan these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated.